Okay, so I'm going to show you how to take limits the easy way, algebraically, but the easy way, practical way of a rational expression or rational function. I'm going to do it with examples. First, we have the limit as x approaches 5 of x squared plus 3 over x minus 1. Now, when you have a limit such as that one, or any of these, the first thing you try is really just substitute the value, x for 5. And in this case, we would have 5 squared, which is 25, plus 3, 28, over 5 minus 1. And in most cases, that's it. 28 over 4, and that would equal the limit. 28 over 4, which is, of course, 7. And you're done. See here, we get a number over a number, and that's the limit. Then we have other cases, like this one says, the limit as x approaches 2 of 4 minus 5x over x squared minus 4. So I'm going to try the same thing. 4 minus 5x, when x is 2, that's 4 minus 10, that's negative 6, over 2 squared, 4 minus 4, over 0. Okay, when we get something like a number other than 0 over 0, well, that simply is undefined. In this case, simply there is no limit. The limit does not exist. You can write does not exist, or you can write undefined. Okay, then we have a case like this one. If we set the limit as x approaches 3 of x squared minus 9 over x squared minus 5x plus 6. I'll substitute again. 3 squared minus 9, it's 9 minus 9, that's 0. 3 squared, 9 minus 5 times 3, 15. That's 9 minus 15 is negative 6, plus 6 is 0. So we have 0 over 0. This is an indeterminate form. Indeterminate. Of course, 0 over 0 is still undefined, but it's an indeterminate form, which means we cannot tell what the limit is without working some more. So when you have 0 over 0, you still have to work it. The way we work it is, in this case, is factoring. So this limit equals the limit as x approaches 3. Now we're going to factor. This is a difference of squares. X squared minus 9 is x plus 3 over x times x minus 3. And x squared minus 5x plus 6, two numbers whose product is 6 and sum is negative 5, those are negative 3 and negative 2. So that's x minus 3 and x minus 2, which means I can simplify, leaving this expression. If I substitute now, 3 plus 3 is 6, 3 minus 2 is 1, so the limit is 3 over 1, which is, of course, 3. So this limit equals 3. So we have the case in which you have number over number, and that's different than 0, so just that's the value. When you have a number different than 0 over 0, there is no limit, or at least no finite limit. And then you have 0 over 0, which means you have to work it some more. You worked it some more, and you could get either of these. In this case, we got 3 over 1, which is 3. I want to do this one. The limit as x approaches 5 of 3. Now, to get the limit as x approaches 5 of 2x cubed minus 16x squared plus 37x minus 35 over x minus 5, well, I notice that I'm going to get 0 in the denominator. So it's either going to be the limit does not exist, or I have to work it to see if, again, I get one of these two. Okay. If I substitute 5 here, 5 cubed is 125 times 2, 250, minus 16 times 5 squared, which is 25. That's minus 2 minus 400 plus 37 times 5 minus 35. It also happens to be 0. So we have 0 over 0. You can check that on a calculator. Okay, factoring this is quite difficult, just like that. So I'm going to see if I can really get x minus 5 is one of the factors from this one and see if they can cancel. I'll do that by division. And I'm going to go ahead and use synthetic division. Alright, because it's x minus 5 that I want to divide it by, I'm going to put the 5 here. It's always x minus the number that goes here. Then the coefficients of the dividend. 2, negative 16, 37, negative 35. Okay, leave a line, leave a space. Okay, the first number simply comes out, 2. 2 times 5, you multiply and write the answer here, 10. And then add. Negative 16 plus 10 is negative 6. Times 5, negative 30. Add, that's 7. 7 times 5, 35. And indeed, the answer is 0. Okay, this represents 2x, this one was x cubed, this one is x squared. 2x squared, 1 less, 1 degree less, minus 6x plus 7. So to write that over there, that polynomial is equal to this one times x minus 5. This one's over x minus 5. So that limit equals this limit, as x approaches 5. Now, I can now cancel. These cancel. And I have the limit of this polynomial, which means all I have to do is substitute. This is equal to 2 times 5 squared minus 6 times 5 plus 7. And so we have 25 times 2, 50, minus 30, plus 7. And that's 27. This limit equals 27. Okay.